Thank you. Oh, cool, it's on. So, I have a lot of experience reading other people's code. I've worked on Firefox for 6 years, and I have dove into a lot of open source projects. And from this, I believe I have learned a bunch of techniques and strategies to make it easier to read code for the first time. So let's talk about that. Turns out, common wisdom is that you just keep reading the code over and over until it makes sense, and then you win. I don't know, I think we can do better than this. And Julia actually made a tweet last year, which I thought was fairly insightful, about how, especially for students, a lot of the exposure you get to projects in classes doesn't reflect what the real world is like in terms of software engineering. There's just a whole order of code that is present that isn't present in your university projects. And that is something that we need to find a way to overcome. So I posit that reading other code is actually a skill that can be practiced and built upon. And it's not the same as just reading syntax that we're taught in classes. We're taught how to read a class declaration. We're taught how to read a function and variable declarations. And we learn how to string those together into programs that will solve a particular goal. Unfortunately, that reading that code and forming a mental model of how it all fits together works for fairly small self-contained programs, but once you get to larger programs, people are not able to keep the whole model in their head at the same time. And we don't learn how to bridge the gap here. So the difficulty of reading unfamiliar code is a combination of two things, and that is the experience you have reading unfamiliar code previously, and the confidence with which you approach the problem of reading this new code. And it turns out that these are things that you get by reading more code, but it's difficult to start with when you don't have those to begin with. And so consider the difference between reading a new part of a project you're already involved in, where you recognize a lot of the idioms and you're aware of all the tools that are already in use. That is less hard than reading code for a different project which uses the same framework and tools. And that in itself is less hard than reading code for a different project that uses a totally different framework. And that is very different than reading code for a project that uses a totally different language. So there's levels of difficulty that you can expose yourself to. So the question is, how can we bootstrap this so that we don't actually require experience to be good at reading code? So for me, what works is that rather than just looking at a piece of code and being a detective and be like, I wonder what these lines do. I try to make use of context. I think of the code that I'm reading in terms of how does it relate to what I know about the actual application that I'm reading the code for does. And with that, I can then make connections and make assumptions which may end up being true or false, but they give me something to jump off from. And additionally, even if I'm unfamiliar with the tools that are used for the project, then I can still try to make connections between what I'm reading and what I have previously experienced in other code. Confidence, on the other hand, this one's trickier, because confidence is one of those strange emotional things that if you don't have it, it's sort of self-fulfilling that you won't end up gaining confidence if you don't do well. So, this doesn't have to be the case. The problem I find with lacking confidence in reading new code is that when I get confused, then I get discouraged. And when I get discouraged, then I despair because I think about how much I need to understand and how much I don't understand, and that is just very sad. So, the trick is actually to embrace confusion and find ways to tame it and not think of it in terms of, I don't understand this, and I won't understand this, and I can't understand this, but think of it in terms of, I don't understand this, that's probably okay. If I need to understand it, I can focus on that, but until then, just ignore it. And similarly, when it comes to despair, as I said, the problem is that it's when I start thinking about the scope of how much I don't understand is when I start losing confidence in what I'm doing. So what I do instead is, rather than saying, all right, I need to understand this whole project that I've been given that has all this code in it, I say, all right, I am going to try to understand this one particular feature. Anything that is unrelated to that feature, I will completely ignore. and I'll focus on just that feature. And therefore, the scope of things that I don't understand radically is minimized, and that makes it much easier for me to focus on the things that will not make me sad. So, I promised that I would document how I undertook an effort to read code for the first time. And to set myself an appropriate challenge, I decided to read the source code of LibreOffice, which is 7 million lines of just code, not even comments or blank lines, across 71,000 files in apparently like 24 different languages, but the main ones are C++, Java, and XML. So LibreOffice, if you're unfamiliar, is a Office productivity suite, and it allows you to create presentations and documents and all sorts of wonderful things like that. And I decided that it would be useful for me to learn about how the charting feature works in this. So specifically, if you go to like a presentation, there's a button here that says like insert chart, and I can click that and I get this chart. And this is a chart which is kind of cool because there's all these options on the side that you can change. Let's see, what if I click on one of these bars? And then I can turn off the x-axis, I can change the title. So there's all these like live updates that happen, and I was thinking, okay, I wonder how they implement this so that there's this like live update responsive stuff. And I wanted to figure out how this worked without having to care about any of the rest of this whole Office suite, because 7 million lines of code is a little bit much even for me. So the tools that I use to accomplish this task are very straightforward. I keep a log of what I'm looking at any given point. I write it down, I think about it. I end up writing things like, let's see. I just write down what I'm looking at any given time. I say, oh, nope, I have no idea what this file name means, shrug, whatever, we'll come back to it later. It's just a matter of keeping a log of what you're thinking, so you can come back to it. I use search tools like grep, acc. They just search contents of files. I look for file names and directory names. And then I use a text editor, which I've customized so that I can be as efficient as possible. And this is really the strategy that I go for. It's avoiding doing as much as possible so I can be as efficient as possible in understanding what I'm doing and what I'm reading. So in particular, acc gives results that look like this. Basically, I said, I'm going to search for the string insert chart, give me all the files in a directory that have that content in them. It highlights it. It's very handy. But I personally find that I'm more useful and effective in a web browser. So I wrote a little Python script that will show me the results of acc searches in a web browser so that I can then open them in new tabs and have history that I can look at. And it's very simple for me that way. I can be very effective. So that's what I'm basing my work on. So there's going to be a lot of searching here. This is really going for the broad overview, figuring out what is actually relevant for us to understand. So I've seen people read unfamiliar code for the first time, and I see a lot of people, like they may search for keywords in the directory. That's good. But then if they find a file which looks like it might be interesting, I see them, they open it up, and they're like, all right, I'm going to start at the top. I'm going to read each line individually. I'm going to make sure I understand what's happening so that I can get a full picture of how this file works. I find that inefficient. Similarly, if people say, all right, I'm going to start with the main function because I know that's where everything begins, and I'm going to follow it down and follow the path of execution so I understand how this program works, that also feels inefficient to me. I think that we can do much better than this. So personally, I start with looking for elements of the user interface, which are unique identifiers that I can search for in the code. They may not be directly related to the thing that I am trying to do or trying to learn about, but they should be able to give me a jumping off point from which to find out more. So in this case, I figured the string insert chart. Like I said, there's that little button in LibreOffice which says insert chart. I figured looking for that would give me a good list of things that I could start from. And that gave us a list that looks like this. Basically, there's about 10 items, and some of them you can look at them and go, oh, this is printing out to standard out, probably not useful. There's a bunch of those, we can ignore them. There's one that's like part of an error message, we can ignore that. So there's the actual results we end up that are worth looking into at the end are much more reduced, just because I didn't go and open up every single one and start reading through them. I actually just take a look and triage. That is the secret to all success. Minimize doing things. However, if you're working on something where you don't have necessarily a user interface to base it off of, then still doing those exploratory searches for keywords that'll be relatively uncommon, that's good. But again, you want to aggressively ignore things. You can always come back to them. You can write them down if you think maybe they're worth coming back to, but focus on the ones that look like they might be the most useful. So, if we go back to that list, we saw there was a file called strings.src, which I haven't seen before. I'll take a look at that. This gives us a file which has, I don't really recognize what this language is, but I can basically see that there is this name associated with this text that says insert chart. And so this says, okay, maybe I should look for this identifier and that'll give me a next jumping off point. So if we repeat that process, then we end up with this list. And this says, okay, there's a really small number of things, and most of them are, there's the file we just looked at, there's this thing which is defining a thing that doesn't look useful, but there's this file, which is a C++ file, and it's got this thing called like gbutton tooltips. That sounds like tooltips for a button. That sounds like something I could probably work with. That sounds useful. And it's even in a directory under UI. This sounds doubly useful. I like this. So what do you actually do when you come across a file that is potentially useful for your purposes? Again, do not read top to bottom. There are very few times when that is actually the most effective way to learn about something, in my experience. I like to use other tools that'll show me like what all the functions are in the file without me having to actually read the functions, or tools that'll show me all the classes defined. Things that will minimize the amount of information shown to me so I have to make fewer decisions. Code folding is really great for that. If you have an editor that'll let you just collapse everything that is not like a top level type or function or something, that's really handy. There's another really neat trick, which is that if you're working on a project which has established history and has a version control system, if you can look at the history of the file, often you'll see commit messages that describe certain changes that were made to that file. And you can look at each individual commit and say, okay, I have the context from the message explaining what change was made, and I can see that like multiple files were changed in this one commit, and they presumably addressed a problem that is being described in the commit message, and therefore you can focus and scope the changes you're looking at to see what changes were made to solve a problem in the past, and that gives you context to help you understand other parts of the file that you can read. So that can come in really handy if you come across a file which you think looks really useful, but you don't necessarily have a sense of what's most important to start reading first. So there's now a process. We've talked about like how to find a broad set of files and then what to do when you're reading through a file at a time. But the point is that this is an iterative process. You want to basically keep a priority queue of things that you want to look into in the future. And you're going to be keeping two things. One is the list of interesting items, like I said, and the other is the list of things that you don't understand. And that's fine. Like I said, we're taming confusion here. We're writing down the things which we read and we go, I recognize the syntax. I know this is valid in this language that I'm reading, but I don't understand its purpose. I don't understand the names involved. I don't know where they're defined. So that's fine. Just write it down the list and move on if you don't think it's actively blocking you from understanding what the rest of the function you're currently reading is doing. And the point is that you don't want to get sidetracked by the things you don't understand, because that's how you end up going down a deep rabbit hole, trying to find out what it does, and in the end you find out, oh, it's just something that like keeps some global log happy, or something that doesn't actually matter for the purpose of what you're trying to understand. And if you reach the end of things in the current file that are actually relevant to you, that's fine. You can move on to the next thing in the list, because you're keeping that priority queue of things that are most interesting to least interesting, but still possibly related. And so you can always just go on to the next one there. And the point is that we want to be doing sort of a breadth-first search rather than a depth-first. We want to go broad rather than deep, because at this point we're just trying to understand one particular aspect. However, if you come to a part of the code that you feel is actually relevant for your purposes, usually you need to have more of a contextual understanding of how that code fits in with the rest of the project. And this is about identifying relationships. This is about figuring out what other code interacts with the code you're reading and how it does so. And there's a few ways to do this. One would be leaning on your compiler. There's a really great blog post by an IBM researcher named Lindsay Cooper where she talks about how she actually needs to fiddle with code that she's reading in order to understand it better. So she will actually do small little experimental refactorings. She'll encapsulate things that look like they're repeated in different methods into a separate function, and she'll then call that instead. Or she'll try marking things as private to see who calls this. The compiler will be able to tell us this. It knows everything. Similarly, you can look for the points of interaction between code. So whether it's other classes inheriting from code you're reading, whether it's other code instantiating code you're reading, or importing it, or including it, stuff like that will allow you to find out how it's being used, and that gives you a broader context. On the other hand, you can focus on understanding it from the point of view of the runtime of your program. If you're using a debugger, then you can say, all right, I am interested in this particular method that I'm reading. I can set a breakpoint here, and anytime this code gets executed, then program execution will be interrupted, and you can then see, oh, this is the list of the current stack frame. Basically, you can see what code actually ends up calling this, and you can read back and get the context around that. Similarly, you can also just add printf statements or print line, whatever is your favorite in your language, just to get a sense of how often this gets called. When does this get called? Does this print execute when I click this button? Is my assumption here correct that this is actually executed as a result of clicking this thing? So these are all great ways to get a sense of this code you're reading in relation to other code that you may not have encountered yet. So, for my search for the chart implementation in LibreOffice, as we saw earlier, we had this file, which is in the user interface directory called View Overlay Manager, and it's got this thing called G-button tooltips, which has insert table, insert chart, insert picture, insert movie. Sounds good. So why don't we see where this is actually used? Let's look for G-button tooltips. So we end up looking at this function here, which is called image button HDL. I don't know what HDL means, but image button seems pretty clear. On mouse enter, that also sounds pretty clear to me. That sounds like something that would execute when the mouse enters this element. Pretty good. I'm looking at this, I'm going, okay, there's some checking of pointer things, something about a view. There's something about highlighting an ID. Okay, not too bad. I don't know what an output device is, probably not important. There's some logic about positioning and things. We do a check about is the current highlight different from the old highlight, presumably. Something about hiding the tooltip, showing a tooltip. There's a lot of things here which the details aren't totally clear to me, but I can infer that they're probably not important for what I'm trying to reason about, which is actually what happens when we click the button. So actually, this function is probably not useful for my purposes because it's about the mouse entering, but not about pressing a button. So tooltips is not used anywhere else, only that one place. But there's this other thing above it called G-button slots, which seems to be the same length and seems to have things which are similarly named but slightly different. So why don't we find out what this SID insert diagram thing is, which corresponds to this string insert chart. If we search for that, we get a bunch of results, and nothing which is, entirely clear what we want here. So, if we look here, one of the results is for this UI func fu insert thing. Now, somewhere in here, we have this thing. We see this thing. There's this. We see a reference to this chart2 xchart document somewhere over here. That sounds interesting. That sounds like a type which might actually be related to an implementation of charting in LibreOffice. That could be useful. I'll write that down. And this function is actually called doExecute, which is interesting. Because in the previous file, we'd looked into the tooltips thing, or the button slots, actually. Look here. If we look at the way button slots is worked, or is used, there's this function called mouse button down. This sounds more like what I'm actually looking for. Something happens when the mouse button is pressed. There's a lot of details here which are fairly confusing to me, not knowing anything about LibreOffice and its internals. But what's interesting is line 305 here, which has this thing called execute. And to me, that suggests maybe this is a design pattern that's based around like executing commands. That's a fairly well-known one that's used for supporting like undoable command execution. And so the fact that there's this thing called execute, and in this other file there's this thing called doExecute, to me this suggests there might be a relationship there, and this might be worth looking into. So this chart2 thing, xchart document, that sounds like something could be useful. And I remember reading some of my, in some of my searches earlier when looking for things related to charting, there was a directory called chart2. So that sounds like a useful place for me to start investigating next. And so it turns out that the chart2 directory is full of all sorts of really interesting things. I mean, there's a ton of files in there. To me, surprisingly a lot of files, given that in my head, like, charting is not actually a difficult problem. But apparently I'm wrong. Because there's actually a bunch of directories called like model, view, and controller, which is nice. That's a pattern that I have heard about, even if I can't really define very well. But I understand that there's like this connection between a model which holds data, and there's a view which like presents data in some fashion, and a controller which like somehow links everything up and says like, when changes happen here, then update the view. So that gives me something to base further reading around. And we actually have this file called chart model, and to me, I thought, well, chart model, if that holds the data, that's probably the most important thing for understanding how charting is implemented. But it turns out it's actually like a really long file, and I skimmed through it, and I didn't see function names which really meant anything to me, and it wasn't very useful. So I decided to look at the views instead, because I figured, okay, I understand the concept of like drawing a chart. So a view of a chart is probably conceptually related to that. And it turns out there were files called like bar chart and pie chart. And those things are concepts I understand, and that actually gave me a lot better sense of what I was reading. Because there was like function called update shapes, and that seemed to be like creating shapes for each bar in a graph. And for the pie chart, it turns out pie charts are way more complicated than I expected, because there's like all sorts of math involved for deciding where you end up placing labels and how like wide things should be. So that's pretty interesting. And then I read the code in controller, and that ends up like creating these. It has methods called like attach view and attach model, and like it just made the connections between these different files far more clear to me when I read that. So that's really cool. That gave me a much better understanding of the actual implementation of charting in LibreOffice, and I came away feeling like if I wanted to know more or understand more things related to that, then I'd have like a much quicker jumping off point because of that. So at this point, if you've gone through the iteration process and broadening out each time you come across something that's actually relevant to you, then at some point you either come to the point where you feel like you have accomplished your goal and you understand enough of what you set out to do, or you have exhausted your list of things you wrote down that were interesting and you're not really sure what to do next. So at that point, if you're not actually finished, if you don't feel like you understand enough, like it's time to start over and time to start that keyword searching again and choosing different keywords this time. Look for different parts of the user interface that might be relevant. But regardless, either way, we have now created a list of things that are both confusing and a list of things we have learned and assumptions we have made and guesses we have decided might be reasonable. And that gives us far more to work with. And we've seen patterns that have emerged in the code we've read. So this gives us far more clarity into what we could ignore, because it's just like it's really common everywhere. You can say, okay, probably not necessary to understand what I'm trying to understand. So if you want to know more about this, I think Lindsay Cooper's blog post is really great. She explains how fiddling with code is more effective for her than just like reading it line by line. Additionally, Aria Stewart is a developer at NPM, and she has a talk which she's turned into a blog post about how to read code, which she focuses much more on how to understand the connections between code and understanding how interfaces are related. And that's a really interesting part to me, but it's different than like just starting with that blank view. And additionally, I have a colleague at Mozilla called Mike Conley, and he actually, he keeps those logs every time he fixes a bug in Firefox, and he writes down his thought processes and what he explores and what he learns in the process, and the assumptions he makes, and he publishes those all the time. So those are really interesting to read, because Firefox is super complicated, and that, personally, I find reading how other people reason about code is interesting and edifying. So that's it. You now understand how charting works just about as well as I do, and that's pretty cool. You can now also read the LibreOffice source or any other project in theory. It's just a matter of limiting the actual information you take in and avoiding doing as much as possible. It's like the best possible way to be lazy. So I've got the slides up there if you want to click on those links, and otherwise, thank you for listening.